Hello everyone. In this video, we're going to talk about two independent sample t-test. As you know that we are on the topic of mean comparison. So this is another mean comparison test. I have my data here. In my last video, when I was conducting one sample t-test, I tested my e-womb credibility. I'm going to do the same again. I'm going to test my e-womb credibility, but this time it would be a little different that I'll be testing e-womb credibility between the two groups. So let's look into the procedure first. How do we perform it? If we click on Analyze, you will look at this tab here that is about option Compare Means. Now within the compare means, we have independent samples t-test. Click on that. I'm just clearing the data, reset, and I want to test the e-womb credibility, and I want to check if it is same across the gender or not. So within this area, grouping variable, I'll just click on gender here. Now I have to define the gender groups as well. Click on gender group. I have two groups here. I have given my male members value 1 and females value 2. I'll just click on continue now, and that's it. My data is there. I'll just simply click on OK. And this will give me the results. Now my results are here. You can see the results are here. What I'm going to do is that I'll copy this result and I'll take it to Word so that I can analyze and write the description related to this test on my Word. Control V. So instead of copy pasting, I'll use my snipping tool and I'll just snip this table and I'll take it to my Word. See, and here's my table. Control V. Now let's look into the data that we have here and we'll see what analysis should we write for it. So what can we see here? We can see that there were two different groups and the mean is given for the male and for the female, and their standard deviation is also given. So we are just going to simply paraphrase this information. Okay. The results show that e-womb credibility among male members. Okay, now I'll put the number of male members here in the parentheses. That would just identify that this is the number of males. Is 3.44, and where do I get this 3.44? This is the value here, 3.44, and right next to it I would insert the symbol of plus minus, and I remember it is here, plus minus 0.71, 0.71, and among, or I can even say whereas it is 3.36 plus minus 0.65, 0.65 among female members. Full stop. So what exactly I've done, I've just paraphrased the information that's given here in the top table. Now I'm going to write about the information that's presented to us in the table below. Now, the first thing that we have to decide is that whether we are going to interpret the data that's given in the top row or the data that's given in the bottom row. How do we decide that? Now, the null hypothesis of the Levene test is that the variances among the both groups is same. So if the sig value is greater than 0.05, we would retain the null hypothesis, which means that if this value, the sig value, is greater than 0.05, we would use the top row. But if it is less than 0.05, we'll use the bottom row. So since in this case our value is greater than 0.05, it means that the variances are equal and we are going to use the top row. So what does the top row tell us? Now if you look at this side here, the t value and the sig value and everything, it would give us some good information. Now, first thing first that we have to look into is that what's the null hypothesis of the t-test, equality of means? The null hypothesis is H0. It says that mean of A is equal to mean of B. So I'm just putting here mean sign, mean A is equal to, actually, so I'll quickly put down my equation here in the insert tab. We have this insert equation and I'm going to write my equation by hand, and it is that x bar A is equal to x bar B. Now this is what I want to put here, that this is my equation, this is my null hypothesis basically. So, and you know the rule of the game, that if t value is greater than 1.96, if p value is less than 0.05, and we don't have a zero between the lower and upper limit of class interval, we reject the null hypothesis. But if you look at it here, you can see that clearly that our t value is less than 1.96, so we can't reject the null hypothesis. We would have to retain the null hypothesis that the means are same. So that's what I'm going to write here, and I'll say that, oops, it's giving me error here, so I'll just quickly edit this. You will say the null hypothesis that mean of male group is same as female group is retained. We can also say supported, and right after this we will have to write it in some special way. We write here CI, then box brackets open, we'll write the class interval value here, that is minus 0.085, comma 0.243, box bracket close, comma t parenthesis open. And what's the degree of freedom that we have here? It's giving us 276. So we'll write here 276 equals to 0.949. 949. You can see that I'm just copy pasting the values that are given in the table, nothing new. Now, this is a question here. Is the p-value greater than 0.05 or less than 0.05? It is greater than the value, and that's what we are going to write here. It's greater than 0.05. So this is a format that you would always have to follow if whether you retain the null hypothesis or you reject the null hypothesis. These are the statistics that you have to report, and we just simply write it this way. If in case we were rejecting the null hypothesis, we would also write what's the difference between the mean of the male and female group. But since it's equal, we are not going to report that, and we're just going to say that it is statistically significantly same. Null hypothesis that the mean of is, maybe we should add here the word statistically significantly same as female group. And that's it. That's our interpretation of independent sample test. Now, you might ask that when do we use it? Uses of this test. We use this test when we want to compare mean of one group of two different groups. That's when we use this two sample test. So that's all in this video for you today. See you again. Bye.